Good morning and welcome to the fourth video on expressions and equations. I have talked to the tech people and they say that my camera will be up and running later, but right now it appears to be not working, so they're going to be fixing that. So this is just an audio only video. Sorry about that. This is a problem from your textbook. So on, I think it's page 207. The school is planning to add a weight room to the gym. If the total area of the gym and weight room should stay under 5,500 square feet, what is one possible length for the new weight room? Show your work. Are there other lengths that would work? Why or why not? So what we have here is we have basically two rectangles. We have two inner rectangles, that is. So we've got this rectangle, which is the gym itself, and we can see that it has a length of 90 and a height of 55, so we could find that area. And then the weight room they're going to add on, and it also has a width of 55 on the left, but it has an unknown length of x. So those are the lengths at the top, 90 and x, but they both have a width of 55 feet. So this is called an area model for what we're going to be learning about today, the distributive properties, that you can set up a multiplication kind of as thinking about it as area. So this is what this equation would look like. And the reason is 55 is the length, or sorry, is the width of the entire gym and weight room. So 55 is the width, and then the entire length would be 90 to start with, but times x. So the area of a rectangle is width times length. And so we are writing this inequality. It's basically an equation, but an inequality saying that 55 feet times 90 plus the new weight room has all got to be less than 5,500 square feet. So this is an example of the distributive property. The distributive property says, well, if we have these two rectangles that I circled, we should find both of their areas. And the area of the gym is 55 times 90, and the area of the weight room is 55 times x. So 55 times 90, the gym on the left, 55 times x, the weight room on the right. And it can be written in these two ways. So on the top, we have it as one length, 90 plus x is this entire length of the gym and the weight room. And now it's broken up into two parts, the gym separately and the weight room separately. This is an example of the distributive property and also of expanding, which we're going to learn about a little bit more. So if we continue to solve the problem, we could just simply find the gym area, right? 55 times 90, that's 4,950. So whatever x is, x times 55 when added to 4,950 would need to be less than the 5,500 we're told. So if you work this out, which we're not really solving equations, but x could be 10 feet. You can kind of show this on your own. You can check it for yourself if you'd like, but 10 feet would be the maximum width of the weight room. So mainly these first two steps, showing the area of the large rectangle 55 times the entire length, and then breaking it up into two inner rectangles. This is what we mean by an area model. Another way to think about the distributive property is like a magical house on Halloween. So rather than giving everyone one piece of candy, it would multiply each person's candy by the same factor. So let's pretend that the person has 9 pieces of candy in their bucket. The magical house would double that to 18. So showing that in an equation would be 2 times 9, doubling 9, right? 2 times 9. But another person might have an unknown pieces of candy, X pieces, but the magical house would also double that. So now it would be 2 times X pieces. And that's the second part of the multiplication. So really there's just 2 multiplications happening. The house is doubling the first person's candy, 2 times 9, and doubling the second person's candy, 2 times X. So we would come up with 18 plus 2X. We use the distributive property to expand expressions. So expanding means to kind of break them apart. So here is another example. We have 4 is the multiplier times 6m plus 18. The 4 is going to multiply the first term, 4 times 6m, and it's going to multiply the second term, 4 times 18. So this is what we mean by expanding, writing the 4 twice, 4 times 6m plus 4 times 18. Doing the multiplication, 4 times 6m is 24m, 4 times 18 is 72. This would be our result after we expand 24m plus 72. Another example, now we have -3 as a multiplier in the front of the parentheses. So the number right next to the parentheses means multiply. To expand looks rather long, but we've written the -3 times 2a, the -3 times a third b, and the -3 times the last term, -2. Sorry, this should be a -1/3 b. That's my mistake from the middle. -1/3 b. And our result, so multiplying, -3 times 2a is -6a, -3 times -1/3 b is positive b, and -3 times -2 is positive 6. So you'll notice we have 3 terms when we're done, just like we started with. So in the parentheses, when we began, we had 2a minus 1/3 b minus 2. That's 3 terms in the parentheses. Same over here. We always get the same number of terms when we're done using the distributive property. And we had 2 terms in the first problem, 2 terms in the parentheses, and 2 terms when we're done. Get the same number of terms, we're just multiplying. We're not combining like terms. So try some of these. Expand each of the following expressions using the distributive property. Here's our first problem. Second problem. Give those 2 a shot, and then I will stop the video after the answers. So the answers for these two expressions, the first one, negative 50w plus 20x plus 30 after multiplying by 10. And the second expression, negative 28d plus 21e after multiplying by negative 7. Thank you for watching the fourth video. Make sure to take your notes, and good luck using the distributive property and expanding expressions.